Welcome to the channel. In today's video, we're going to talk about bananas. Welcome back. We're talking about bananas. And as you can tell, this banana is quite yellow, has some brown spotted patterns, and you probably know this by now that this banana will be particularly sweet. But I want to show you what happens chemically through the lens of a near-infrared spectrophotometer as a banana goes from green to yellow. This process is known as ripening, and generally what happens is that larger starches are broken down to simpler sugars like sucrose and fructose and glucose, and thus the banana appears to be much sweeter. Tannins are also converted, and so generally this is a very pleasurable process because now the banana is much sweeter and fun to eat. But because I am an analytical chemist, I wanted to look at this process using a near-infrared spectrophotometer. Now, as you can imagine, we're not necessarily going to see exactly the type of sugars that are being converted, but we do expect there to be some chemical changes that are measurable through the lens of a near IR. And because we have this device at home, we can measure this over several days and then look at that data. So during December 2024, I actually performed this analysis, and in this video, I want to show you what this data looks like and how we can visualize it in a number of different ways. And so let's get started. So what I'm showing you here is the raw data from the banana. This is a CSV file, and we're looking at wavelengths 1450 to 2450. And you can see that the CSV is a comma separated file. We have wavelengths, we have absorbance values, and then we have all the actual intensity values there, as well as a lot of other information we don't quite need in this study. Here are the wavelengths, the column headers. So what I want to look at first is our color notebook. And in this notebook, we're going to drop several columns from the raw data that we don't need. And this is important because we don't need to carry all this information throughout our analysis, although it's going to be kind of short in this video. But you can see we're going to read this data here from our banana color and then drop these several columns. And then we're also going to perform some standard normal Fourier transformation just to clean up the data. Let's select the kernel and run this cell from the beginning. And you can see a preview of the data. So we began our experiment on December 16th. We measured again on the 17th, 18th. I skipped a couple days because it was still green. And then again on the 21st. And we have that data here. So for data visualization, I want to try something a little bit different. Normally, I would just create a general line plot, and I will show you that. But I was looking through the Seaborn gallery, and you can see the URL there at the top. And it has a number of different examples of plots that you can make from, depending on what your data source is. And so I wanted to try to make a different type of plot that I haven't really explored before. And there are several different options. And in this case, I was looking at a rel plot. And here you can see that we have multiple time series here. And the line of interest is the one that is colored, but you can see the context from the rest of the lines. And I thought this was a really cool plot. You can see that it takes a combination of a couple of different pieces. We have a for loop to help us iterate through and assign new values to the line plot. We're modifying the base rel plot there. And so it's kind of interesting. And so I wanted to apply this type of plotting to my data, even though the data set that I'm currently using is a little bit smaller. So before we do that, let's just create a standard plot. Using this, I'm going to use a custom color map where we're going to begin with green and end with this yellow color, convert that to a color map, and then use that color map in this dataframe.plot function, and then set the figure size to 12 by 6, and then despine the plot, and then show and render that plot. And you can see this is a typical line plot. And as we go from green on December 16th to yellow, you can see that there are some changes in the approximately 1700 nanometer area and in the 1900 nanometer region that are pretty interesting and seem to be correlated with time in some manner. And so we can already see that there are some chemical differences that are detectable using near IR from a fresh banana to a more ripened banana. And so I want to now try this other type of plot, this rel plot, and adapt some of that code from the example in Seaborn. When I do that, I came up with this here where I'm going to use the same C map, but I've got to set my color map as false in order to make this whole process work, as opposed to true like we did before. And as you saw in our example, I have my base rail plot where I'm going to pass in that same data frame. I'm going to melt it to reshape. So I have my index values, my date, and my values. And then I'm going to use that to assign my X, Y, and column. I'm going to set the column by date and then also color by date. And then I'm going to set my column wrap to 2. So that my overall figure will be 2 figures wide, 2 columns wide. And then my aspect ratio to be essentially 2.7. Next, in order to update each subplot, I'm going to use this for loop as you saw in the example file before. You can see we have this for loop where we're going to iterate through our date and each axis. And I have my date and each axis there. And then we're going to apply this transform to get the text and then use a customized line plot over a subsection of the figure to create our overall plot. And then we're going to modify our X ticks as well as making sure the title is blank, setting the axis labels to what we want, and then using a tight layout. When we do this, you can see that we are generating generally the same type of plot where we can see our dates, December 16th, 17th, 18th, and 21st. And if we look closer, come to this view here, you can see that for the 16th, we're on the green line that's a little bit lower. As you move to the 17th, it's a little bit less green, more yellow, and slightly higher. Because my lines are so close, it's not as visually appealing. As you move to the 18th, you can see we're now on the top set of lines here. And then as we go to the 21st, we're on the more yellow line, and it follows the same trend as we saw here. Now, this data set was kind of small for this type of figure, but I wanted to show you how, because we have access to the Seaborn Gallery, we can seek inspiration from a number of different types of plots. And because of this, we can then explore new ways to visualize our data. It's nice to explore here. So now we have the base code that if we want to apply this to a larger data set, we can apply this same code and make slight modifications, and it's already in our data visualization repository. And this is how I tend to practice with getting new examples and being ready and when I work and I need to make these figures. In the next video, I want to show you what happens if I damage a banana. So many times if a banana gets bruised, you will see that there's a brown spot that begins to form. I'm going to take the same instrument and monitor continuously over the next hour of that damage to see what happens chemically, if there's anything we can monitor or changes we can see during that process. If you want to be notified when that video comes out, like, comment, subscribe, and I'll see you in the next one. Peace.